Have you ever noticed how summers seem to be getting hotter while winters are becoming colder? Ever wondered why this is happening? The shifts in weather patterns around the globe are telling a story of climate change, a reality we can no longer ignore. One of the most striking chapters of this story is the intensification of summer heat and the deepening cold of winter. While it may seem contradictory, these changes are interlinked, and the thread that binds them together is global warming. The human activities of burning fossil fuels and deforestation have led to an increase in greenhouse gas emissions, trapping more heat in our planet's atmosphere. This has caused the average global temperature to rise, contributing to extreme weather conditions. To understand why these changes are occurring, we first need to delve into the science behind global warming. The main culprit behind these weather changes is global warming. This phenomenon is largely driven by human activities, particularly the burning of fossil fuels like coal, oil, and gas, as well as extensive deforestation. These activities increase the concentration of greenhouse gases in our atmosphere, creating a kind of thermal blanket around the Earth. This blanket traps heat, causing the Earth's average global temperatures to rise. This rise in temperature is not evenly distributed and leads to extreme weather conditions. In some regions, summers have become unbearably hot, leading to heat waves and droughts. In others, winters have grown bitterly cold, with heavy snowfall and freezing temperatures. But you might ask, if the Earth is warming, why are winters getting colder? The answer lies in the dynamics of the polar vortex. Tune in for the next part of our series to delve deeper into the polar vortex and how global warming is impacting our winters. The polar vortex and the jet stream play crucial roles in defining our winter weather. Now let's peel back the layers to understand how they contribute to colder winters. The polar vortex, a large swirling mass of cold air encircling the Earth's poles, is at its strongest during winter. But when it weakens or gets distorted, it's like a container with a loose lid. Cold Arctic air can spill southward, causing a significant drop in temperatures in regions that usually enjoy a more temperate climate. Next up is the jet stream, a high-speed highway of air in the upper atmosphere that shapes our weather patterns. But as the Arctic warms faster than the rest of the planet, the temperature contrast between the Arctic and mid-latitudes decreases. This weakens the jet stream, allowing it to meander like a lazy river. As it strays from its usual path, it carries with it frigid polar air masses, driving them farther south. This phenomenon is part of what's known as Arctic amplification. As global warming pushes temperatures higher, ice in the Arctic region melts, reducing the temperature difference between the Arctic and temperate latitudes. This reduction in temperature gradient can slow down and cause the jet stream to meander even more, allowing cold Arctic air to penetrate further south. Now, let's not forget about the role of increased snowfall. Warmer temperatures can lead to more moisture in the atmosphere. In some areas, this results in heavier snowfall during winter, which adds to the chill. Lastly, changes in our oceans play a part too. Global warming can alter oceanic currents and temperatures. Any changes in ocean circulation patterns can impact regional climates, potentially causing colder winters in certain regions. So while global warming generally leads to higher temperatures, the dynamics of our atmosphere and oceans can create pockets of extreme cold. On the flip side, the warming of our planet is most evident in our increasingly hot summers. Our summers are not just getting a little warmer, but they are becoming significantly hotter, and the reason is multifaceted. Firstly, we have the notorious greenhouse gas effect. Greenhouse gases, such as carbon dioxide and methane, are like an invisible blanket around the Earth. They trap heat in the atmosphere, causing a rise in average global temperatures. This effect becomes particularly pronounced during summer, leading to soaring temperatures and heat waves that can be both uncomfortable and dangerous. Next, we have the changes in atmospheric circulation. The warming of the Earth's surface doesn't just cause temperatures to rise, it alters the very patterns of our atmosphere. This can lead to the persistence of high-pressure systems, which act like giant lids on our atmosphere, trapping heat and preventing the dissipation of warm air. The result: regions experience prolonged periods of scorching weather, turning what might have been a pleasant summer into an unbearable heat wave. Last but not least, we have the reduction in snow and ice cover. As our planet heats up, glaciers retreat, snow cover decreases, and sea ice diminishes. This might not seem directly related to your hot summer, but it's a crucial piece of the puzzle. These icy surfaces have high albedo, meaning they reflect a lot of sunlight back into space. But as they shrink, they're replaced by darker surfaces, like water or rock, that absorb more sunlight and heat. This creates a feedback loop, where more heat absorption leads to more warming, which leads to more ice melting, and so on. The end result? Even hotter summers. These factors combine to create the sweltering summers we have been experiencing. It's not just about feeling uncomfortable in the heat. These rising temperatures have serious implications for our health, our ecosystems, and our planet as a whole. So next time you're sweating through a heat wave, remember, it's not just a hot summer day, it's a symptom of our changing climate. In conclusion, the phenomena of hotter summers and colder winters are interconnected aspects of climate change. The intensification of summer heat and the deepening cold of winter are both driven by global warming, a result of human activities, primarily the burning of fossil fuels and deforestation. We've explored how the disruption of the polar vortex, changes in the jet stream, Arctic amplification, increased snowfall, and oceanic changes contribute to colder winters. At the same time, the greenhouse gas effect, changes in atmospheric circulation, and reduced snow and ice cover are amplifying summer warming. These manifestations of climate change underscore the complex dynamics of our Earth's climate system. They are not isolated incidents, but part of a larger, interconnected web of changes occurring on a global scale. As we continue to see these changes, it's crucial for us to understand the science behind them and take action to mitigate their impacts.